Okay. Good evening. Good evening. Last day we started time domain analysis and we discussed time domain specifications last day. Delay time, race time, peak time, settling time, everything we discussed. So today we'll try to complete this chapter. At the end, we'll try to solve the problems in chapter 2. We'll see. So now, note on the problem. Last day we solved the problems related to first order systems. Okay. So that is exponential rise, exponential decay are the responses of first order systems. So oscillatory responses for second order systems. Okay. So next, note on one problem. The unit step response of a unity feedback system. Unity feedback system is shown in figure. Find the following factors. Find the following factors. You also draw it and try to solve it. 1 second. This is 5. First one, peak overshoot. Second one, percentage of peak overshoot. Third one, damping ratio. Fourth one, natural frequency of oscillations. This is called damped frequency of oscillation, omega D. Natural means constant amplitude. Constant amplitude. This is called omega M. This is omega N. This is omega D. Decreasing amplitude is omega D. Last day one fellow asked. Small thing. Natural frequency or undamped frequency of oscillations. Delay time. Sixth one, race time. Next, settling time. For plus or minus 2%. Next, closed loop transfer function. Or transfer function to the given response. Next, output equation. Output equation for response, for the given response. Come on, do it. Come on, solve it. MP is 1. Percentage of MP is 25%. Find zeta value. Come on, solve it. First, find peak overshoot. What is the formula for peak overshoot? C of Tp minus C of infinity. That means C of Tp is 5. C of infinity is 4. This is C of infinity. So that means 1. Next, percentage of MP. Percentage of MP equal to C of Tp minus C of infinity by C of infinity into 25%. That equal to 5 minus 4 by 4 into 100%. That equal to 25%. Next, find the zeta value. Find the zeta. Anybody? Zeta. 0.403. 0.3423. Come on, tell the correct answer. 0.403, I think correct. 0.403. Damping ratio is 0.403. Damping ratio we can obtain from MP. Even we can obtain from percentage of MP. Both the things you can find. For example, I'll find with both same. For example, I'll take MP. MP equal to what? AK into AK into e power minus default pi zeta. N is 1. Divided by root of 1 minus zeta square. What is MP? 1. What is AK? This is called AK. This is called AK. A is called amplitude of input. Amplitude of input mentioned unity. Means K equal to 4. AK is 4. So write it here. AK 4 into e power minus pi zeta divided by root of 1 minus zeta. Next, 0.25 equal to e power minus pi zeta divided by root of 1 minus zeta square. Apply ln and solve for zeta. Apply ln on both sides and solve for zeta, you will get 0.403. No, sir, I will use percentage of MP, means same. If you use R percentage of MP equal to e power minus pi zeta divided by root of 1 minus zeta square into 100%. Percentage of MP 25%. equal to e power minus pi zeta divided by root of 1 minus zeta square into 100%. Then if the 100 comes this side divided by 100, then it will get 0.25 equal to e power minus pi zeta. Divide same thing, 1 minus zeta square. Both are same. You find zeta, you will get 0.403. This is the answer. Either go by percentage of MP or MP. The answer is same. Next, after finding zeta, next find, this is for third case, third problem. Next, fourth one is omega n you have to find. Fourth one is omega n you have to find. So for omega n, Tp given. Tp equal to 1 second given. So what is Tp tell? Pi by omega d. Tp given 1 equal to pi by omega d equal to what? You can write even omega d. So omega d. So what is omega d? Pi. Pi means 3.1414, 3.14 radians per second. Next, get the omega n. So pi equal to, you take exact value, no problem. Omega n into, what is omega d? Omega n into 1 minus zeta square. Now find omega n. So pi by root of 1 minus zeta square. What is zeta? 0.403 whole square. Get the value of omega n. Get the value of omega n. What is omega n? 3.43. Correct. 3.43 radians per second. 3.43. Next, omega n completed. Next, what happened? Delay time, TD. 1 plus 0.7 zeta by omega n. Find the delay time. Find the delay time. How much? Delay time. 0.37. Correct. Delay time is 0.37. So 1 plus 0.7 zeta 0.403 divided by omega n 3.43. Solve it. You'll get 0.37. Next, find raise time. Next, raise time, TR. Pi minus cos inverse zeta by omega d. Pi minus cos inverse zeta by omega d. What is the answer? Delay time. Delay time 0.63. Raise time. Raise time is 0.63 seconds. Just substitute na. Pi minus cos inverse of zeta divided by omega d. Keep calculator in radians. While calculating raise time, otherwise pi means it will become degrees. Keep calculator in radians. While calculating raise time, calculator should be in radians. Calculator should be in radians. Calculator should be in radians. So you solve it, you will get 0.631 seconds, I think. Next, 7. After resistance settling time for plus or minus 2%. What is settling time for tau? That is 4 by zeta omega n. 4 by zeta omega n. Come and solve it. 4 by zeta omega n means 4 by zeta 0.403. Omega n is 3.43. So what is the answer? What is the settling time? Settling time. 2.89. 2.89 seconds settling time is. Next closed loop transfer function, I think, 8th one. So what is the closed loop transfer function? K into omega n square by s square or transfer function. Given system closed loop na mentioned feedback. 2 zeta omega ns plus omega n square. So AK equal to 4. But unit step input mentioned. That means A is 1, K equal to 4. So that means 4 into omega n square 3.43 whole square divided by. Better I'll write in the. Here I'll write 4 into 3.43 whole square by s square plus 2 into zeta 0.403 into 3.43 s plus 3.43 whole square. This is the transfer function. Next, last response. What is the response? Tell C of t equal to what I told? AK into 1 minus e power minus zeta omega n t divided by root of 1 minus zeta square sine of omega dt plus cos inverse of zeta. Substitute here all the values. AK means 4 into 1 minus e power minus zeta 0.403 into 3.43 t divided by root of 1 minus zeta square 0.403 whole square. Sine of omega d means pi t plus cos inverse of zeta means 0.4. Or pi means 3.14. Plus cos inverse of zeta is 0.403. So that's all. This is the answer. So like this, you have to find all the specifications. Okay, na? Right. Okay. Next problem. Next problem. Write it. The impulse response of A Unity feedback system is C of t equal to e power minus 3t sine of 4t. Default u of t you can write at t greater than 0. Find the following factors. Find the following factors to the unit step input. Find the following factors to the unit step input. Because time domain specifications are defined for only step input. That's why find the following factors for step input. But given is impulse response. First one, find omega n. Second one, zeta. Third one, delay time. Fourth one, rise time. Fifth one, peak time. Sixth one, percentage of peak course. Sixth one, seventh one, peak or suit. Eighth one, peak value of the response. Peak value of the response. Peak value of the response. Next. Any more? That's all. Find it. Come on. Settling time. TS for plus or minus 2%. Come on, do it. How to find minimum means what, man? What is minima? Time required to reach minima, that is 2 pi by omega d. 2 pi by omega d is the time required to reach the first minima. Or n value put it. Then you will get the what? Overshoot. Undershoot you will get. Want this in case. This is what? What is n value 1? What is the formula for percentage of MP or MP e power minus n pi zeta? Na? N value change it. That's all. N1 here, n is 2. Then you will get this value. This MP will get. Here n is 3. Here n is 4. Just what? How to find minimum means what minimum? What do you want? Time, peak or sota? Clearly should write na. Right. This is called maximum value. You can say even this is C of TP. This is also we can say C of TV, we can say value point. So 1 minus MP gives the minima. 1 plus MP gives the what maxima? Or AK plus MP gives the maxima. AK minus MP gives the minimum value. Right, next, come on, solve it. Right. First, find the transfer function. So find the transfer function. What is the transfer function? Tell. Laplace of impulse response. Laplace of impulse response with initial conditions 0. So what is impulse? Come on, apply Laplace transform. Laplace of e power minus 3t sine 4t. That equal to 4 by s plus 3 whole square plus 4 square. That equal to 4 by, expand the denominator, s square plus 6s I think, plus 9 plus 16 means 25. But it is not in a standard form. So I can bring into standard form by multiply and divide with 25. I can write 4 by 25. Then I can write here 25 by s square plus 6s plus 25. S square plus 6s plus 25. This 4 by 25, this 4 by 25 affect the steady state value. Affect the steady state value. Affect the steady state value and peak overshoot. That's all. It never affect the time domain specifications. Affect the steady state value and peak overshoot, but not any time domain specification. It never affect the delay time, raise time, nothing, peak overshoot, percentage of peak overshoot. It never affect any more value. Now come on, find the omega n. First find omega n, first bit. Omega n, how much? 5 radians per seconds. Next, 2 zeta omega n equal to how much? 6. Find zeta, 0.6. Next, third bit. Come on, find one by one. We find delay time, raise time. Come on. Come on. 15 or 25 na? 9 plus 16, 25. 15 you written wrong. Check it. Zeta 0.6. Very good. Next. Come on, delay time. You should solve. I should not solve, Guruji. Delay time. Already formulas I written many times na. 1 plus 0.7 zeta by omega n. What is the answer? I think delay time is 0.284. Correct? 284 seconds. Is it correct, Guruji? Check it, Aya. Either 1 by s or all these factors for 1 by s only. Why you are thinking about 1 by s? Right. This is a C of s bar of s transfer function. From the transfer function, you find this factor. Why you are thinking 1 by s? Because of 1 by s, the response varies at around 1. That's all. Nothing will be changes. Right. Next. Next, fourth one, race time. Fourth one, TR. 5 minus cos inverse zeta by omega n. What is the answer? Race time. 0.55. Very good. 0.55 seconds. Next, sixth one. Next, fifth one, TP. TP for first peak. First value means here 2 pi. First peak means pi by omega d. Value 1, 2 pi by omega d seconds. So TP equal to pi by below omega d, find omega n root of 1 minus zeta square. Solve it. What is the answer? Omega d equal to omega n root of 1 minus zeta square. What is the answer? 4. Omega d 4. Okay. Omega d 4. Pi by 4, I think. Pi by 4, correct. What is the answer? 0.71, I think. Come on, solve it. Remain all. Come on, jaldi karo, all of you. Abdul.
సార్ ఇందాక ప్రాబ్లం లో టీపీ మనం టీఆర్ ఏమో పై మైనస్ కాస్ ఇన్వర్స్ జీటా బై ఒమేగా డి తీసుకున్నాం. ఇక్కడ కాస్ ఇన్వర్స్ ఒమేగా ఎన్ ఎందుకు తీసుకున్నాం సార్?
ఇది ఒమేగా డి ఓన్లీ ప్రింట్. బై మిస్టేక్ ఐ రిటర్న్. ఫార్ములాస్ ఇస్ నోనా?
అదే ఒమేగా డి కదా నాకు డౌట్ వచ్చింది.
ఒమేగా డి ఓన్లీ. వై యు ఆర్ గెటింగ్ డౌట్? ఒమేగా డి ఓన్లీ. ఓకే.
ఒమేగా డి అంటే 1 minus. ఓకే సార్.
Damped oscillations, omega n into root of 1 minus zeta square find.
అది తెలుసు సార్. అంటే మీరు ఒమేగా ఎన్ రాశారు కదా అందుకని.
ఓకే రైట్. నెక్స్ట్ కమాన్. నెక్స్ట్ కమాన్ జల్దీ TP 0.71. Some students asking when syllabus will complete. That depends on how many. My syllabus will complete by end of this month, I think. Before that only I will try. Based on the schedule, how much a given schedule for 13. After that, how many hours you will give, I don't know. Na? If same schedule continue, before the end of this month, I will close. Okay. Next, come on. Next, sixth one. Percentage of MP. Come on. Percentage of MP. E power minus pi zeta divided by 1 minus zeta square into 100%. What is the answer? E power minus pi into zeta. Zeta is 0.6, I think. Root of 1 minus 0.6 square. So get the answer. Percentage of MP. How much? 9.48. 478. 9.478. Is it correct? Correct, na? 9.478. Right. MP how much? MP? MP. Not 94% as a Guruji. 9.47. 9.478, I think. Next, find MP. Approximately 9.48. You take, no problem. 478 and 48. Next, come on. MP. 7th bit. What is MP? Tell. MP equal to AK into E power minus pi zeta divided by 1 minus zeta square. Come on. AK. What is A? 1. What is K? K is what? 4 by 25. 4 by 25 into E power minus pi zeta. Zeta is 0.6 divided by root of 1 minus zeta square. 0.6 square. What is the answer? Anybody? 0.01516. 0.01516. Some students MP means they'll remove the percentage and they'll write 0.09. Wrong, it is wrong, aya. Don't remove the percentage. MP different, MP depends on A and K. Percentage of MP different. ठीक है ना? Next, peak value of the response. 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 Peak value means, listen, for example here, this is T. This is C of T. This is 0. Steady state value AK na? AK. AK is how much here? 4/25. Means 0.16, I think. This is AK. Now, MP, if we draw the response, we are getting like this response. If we draw the response, this is got MP. This MP you got, how much you got MP? MP equal to, we got MP is how much? 0.01516. Then this is called C of TP. This is called peak value of the response. What is the formula for peak value of the response? Means C of TP equal to AK plus MP. AK plus MP is called peak value of the response. AK plus MP. What is AK? 0.16. Plus MP is what? 0.01516. That means what you are getting? 0.17516. This is called peak value of the response. If you have any doubt, you check the percentage of peak course, so you will get the 9.48 only. How to check percentage of peak course? Formula what? C of TP minus C of infinity divided by C of infinity into 100% use. You will get 9.48. C of TP is how much? 0.17516 minus C of infinity 516 divided by 0.16 into 100% use. You solve it, no doubt, 9.48% only. It never change. So this is called peak value of the response. Next, what I ask? Next, what I ask? Settling time. So next, settling time. 9th bit, plus or minus 2% you find. Settling time equal to what? 4/zeta-omega-n. Find the answer. 4/zeta-omega-n. What is the answer for settling time? 1.33, I think. 1.33. So that's all. 1.33 seconds. Like this, you have to solve. Okay, na? Right, very good. Good. Next. Okay. One more thing here. Sometimes in the exam, here what is given? Impulse response of unity feedback. Because of impulse response mentioned, directly we are able to find the transfer function. From the transfer function, we will find the specifications. So all the factors we will find. Sometimes what happens, the error signal in the feedback control system, like this they'll mention, in the feedback control system or in control system, the error signal is error signal or actuating signal, error signal or actuating something, some terminology. We don't know also, actuating something you'll mention. So something theta, E or something you'll mention, like E power minus 3t sine 4t, like this terminology will give. Or 1 minus E power minus 3t sine of 4t plus theta, something they'll mention. Like this they'll give. They'll ask the peak course is omega n is some factor, delay time is, raise time is, something they'll ask. So then we cannot find a transfer function. Na? Simply be remember whatever it is, it may be error signal, it may be ramp input, it may be step input or any input, whatever it is, any signal, exponential power is real part of pole. Exponential power is real part of the pole. Real part of the pole. Be remember. Already I told. And sine or cos function is imaginary part of the pole. Sine or cos function is imaginary part of the pole. So be remember, in any system, in any signal response. So what is the conclusion? In any signal response, any signal, in any signal or in any signal response or signal, whatever it is, the exponential power is exponential. The exponential power is a real part of the pole. And sine or cos function is imaginary part of the pole. Just to represent the pole, then get it, that's all. So once you get it, real part gives the time constant, imaginary part gives the frequency of oscillation, omega d. Previous case, if you take it, what is given? For example, previous case, what is given? Example, C of t, what is given in previous case? E power minus 3t sine 4t given. Even it may be 1 minus or t minus, whatever it is, secondary, exponential power, take real part. Sine or cos, you take it, what? Imaginary. Because if 1000 times you integrate also, e power minus 3t will become e power minus 3 only. It won't become 4 here. Sine become cos, cos become sine, but this 4 never change. It won't become 5. That means poles locations are never going to be changed. That's why blindly what happened? You represent a pole. This is minus 3 real part of pole. Then this is imaginary part of the pole. That is J4 plus J4 minus J4 minus J4. That's all. So minus 3 real part of pole, sine or cos function. Now we can take it as this is omega d. Imagine complex conjugate poles now, omega d equal to 4 radians per second. This is called tau. This is what? Tau or minus zeta omega n. Minus zeta omega n is a real part equal to minus 3. Minus zeta omega n equal to minus 3. Zeta omega n equal to 3. Then we can get all the factors. This diagonal distance is called omega n. The diagonal distance is called omega n. This is called theta. Zeta equal to cos theta. Zeta equal to cos theta. Then we can get all the factors. So by once you represent the, what is the diagonal distance? This is 3, na? This is 3. This is 3. This is 4. What is the diagonal distance? 5. That means omega n 5. Omega d 4. Theta you find, for example. What is it? Cos theta. Cos theta equal to adjacent by diagonal 3 by 5, 0.6. That is nothing but zeta. So we can get again all the factors. So be remember, if anywhere you seen signal or equation, in any equation, any signal response or any equation, you write here any equation or any equation or any equation, exponential power is real part of pole, sine or cos is imaginary part of the pole. Then proceed and then get the answers. Okay, na? Okay. Like this, you can solve. Same answers you will get. Okay. Next. Next one. Next problem. Find the percentage of peak core shoot. Find the percentage of peak core shoot. C of S by R of S equal to 100 by S square plus 25. Come on, find. Find the percentage of peak core shoot. %. Very good. So zeta 0 here. Zeta 0. Zeta 0 means undamped system. Undamped system. Zeta 0 means undamped system. Undamped system. Percentage of MP you find. E power minus pi 0 into 0 divided by root of 1 minus 0 square into 100%. E power 0 is 1, so that means 100%. So percentage of peak core shoot is 100%. Percentage of peak core shoot is 100%. So it is 100%. What is the meaning of 100% peak core shoot? Anybody? What is the meaning of 100% peak core shoot? 25% peak core shoot means what? 25% peak core shoot means what? For example, it is 1. 25% peak core shoot means above the input 25%. Above the input 25% is more than the input. Above the input 25% is more than the input. That means, so in a 25% means what? 0.25. That means it goes to 1.25. 50% means 50% more than input. That means 1.5. 100% means what? Double. 100% means double. So more than input 100% more means again 1. That means that's why undamped system either you observed or not, the peak value is 2. Why? Because 100% peak core shoot means the peak value of the response is double to the amplitude of the input. 100% peak core shoot means peak value of the output is double to the amplitude of input. 100% peak core shoot means 100% peak core shoot means peak value, the peak value of the output, peak value of the output, peak value of the output is double to the amplitude of input, double to the amplitude of input, double to the amplitude of input, double to the amplitude of input. 100% peak core shoot means peak value of the output is double to the amplitude of input. ठीक है ना? Next. ठीक है? What is the question here? Question I didn't write. Find percentage of peak core shoot. Next. Similarly, one more problem. Find percentage of peak core shoot. C of S by R of S equal to 25 divided by S square plus 10S plus 25. Come on, do it. 1. So peak coefficient is 1. So here omega n is 5. Zeta equal to 1. Means critical damped system. Critical damped system. Critical damped system. So now what is the percentage of peak coefficient? E power minus 5 zeta, zeta 1 divided by root of 1 minus 1 into 100%. Na e power minus infinity, how much? 0%. Critical damped system 0% because there is no oscillations. 0% means no oscillations. No oscillations. How can you get the overshoot? Tell. No oscillations. What is the response for critical damp? Like this you will get. Is there any overshoot here? Is there any overshoot here? There is no overshoot. How can you get a no overshoot? 0%. In this case, 100% overshoot. You want to find percentage of MP. C of TP2 minus C of infinity 1 by 1 into 100. How much you are getting? 100% you are getting here. But here, there is no oscillation, 0%. And what you understood here? When zeta 0, we are getting zeta equal to 0. We are getting percentage of MP is 100%. Percentage of MP 100%. And the same way, zeta equal to 1, percentage of MP we are getting 0%. That means as zeta increasing, zeta is increasing or decreasing? 0 to 1 means increasing. As zeta increasing, percentage of MP is decreases. As zeta increases from 0 to 1, as zeta increases from 0 to 1, then percentage of MP decreases from 100% to 0%. 100% to 0%. As zeta increase from 0 to 1, percentage of MP decreases from 100% to 0%. That means zeta and MP both are opposite. That means zeta and MP both are opposite. Be remember, zeta and MP both are opposite. Zeta increase means MP decreases. So zeta increases, MP decreases. So be remember this. Okay. Next, if zeta greater than or equal to 1, what happened? Tell. If zeta greater than or equal to 1, what happened? If zeta greater than or equal to 1, then percentage of MP equal to how much? 0 degrees. Sorry, 0. Percentage of MP equal to 0% because there is no oscillations in the response. 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 No oscillations. There is no oscillations in the response. ठीक है ना? Next one. Next question. Completed? Right. Next question. Right. Find the variation in time domain specification. Find the variations in time domain specifications. Find the variation in time domain specifications to the given poles path in the S-plane. Poles path in the S-plane. To the given poles path in the S-plane. To the given poles path in the S-plane. Draw this diagram. One dash, two dash, three dash. Come on, do it. Come on. This is j omega. Find the variations in time domain specifications. 1 to 3 oscillations increases. Good. Next. TP decreases. Next. TD decreases. Time constant same. See, how to do the analysis means simple logic. Listen, all of you. Listen, all of you. First observe the real part. First observe the real part. What happened? Real part of pole pole. All this is same. Real part is same, na? As the real part of the pole is same, time constant is same. Real part same. Real part is same. Real part of poles is same. Poles is same. As the real part is same, time constant is same. Tau is same for all. At tau is same, settling time is same. TS is same, that's all. Settling time is same. Real part of the pole is same, hence time constant same, settling time same. Next, what about imaginary part? Imaginary part is go on increases. Imaginary part increases. Imaginary part increases. Imaginary part increases. Imaginary part increases means what happened? Omega D increases. Omega D increases. Imaginary part represents the omega D. Whole on imaginary means omega n. Imaginary, but it is what having real and imaginary, but imaginary part. This is damped oscillation, a damped pole. So omega D increases. So omega D increases. What about omega n? What about omega n? The diagonal distance from origin to pole, how much increasing or decreasing? The diagonal distance from origin to pole, increasing or decreasing? That is called omega n. The diagonal distance. So omega n is increases. Diagonal distance from pole to origin increasing. That means omega n increases. Omega n increases. What about theta? What about theta? This is theta 1. This is theta 3. What happened? Tell. Theta 3. What happened? theta 1, this is theta 1, this is theta 3. So theta increases. Theta increases. Theta is increases. Then zeta equal to what? Cos theta. So that means theta increases. For example, theta 90, cos 90 becomes 0. That means zeta decreases. So as theta increases, angle, inclination of the pole theta increases, the damping ratio zeta decreases. As zeta decreases, percentage of MP increases. So simple logic, theta and MP both are proportional. Large theta, large peak coefficient. Small theta, small peak coefficient. From origin to pole, if you observe the angle, based on the angle, we can decide peak coefficient. If angle is very, very large, then the what happened? Peak coefficient also very, very large. Peak coefficient also very, very large. So large peak coefficient makes the system less relative stable. Large peak coefficient makes the system less relative stable, and more oscillatory. Whenever peak coefficient is very, very large, blindly we can say that the system is less relative stable and more oscillatory. Finally, what I can conclude, tell the vertical moment of the poles means this one. The vertical moment of the poles, zeta decreases, and system becomes less relative stable. Zeta decreases, system becomes less relative stable. Vertical moment, as per RH criteria or in stabilities, what they used to say, real part is same. So what they used to say, all are having same relative stability, it is wrong. So RH criteria, first of all, it never gives the poles location. RH criteria cannot give exact relative stability, that is approximate only. Exact relative stability want, we should know the real part of pole as well as imaginary part of the pole. Based on that only we can find the relative stability. As real part same, imaginary part increases, the relative stability of the system is going to be decreased. The relative stability is decreases. Okay, na? So write all the points. First point, this one already we written. Real part of the pole is constant. Time constant is same. Next point you write. Come on. As the imaginary part increases, 1 minute. Right. As the imaginary part increases, second point. As imaginary part of pole increases, imaginary part of pole is increases, then omega d increases, then damped oscillations, omega d increases. As omega d and diagonal distance increases, omega n increases. So third one, as the distance from origin to pole increases, as the distance from origin to pole increases, I don't write for remaining things, you should write by yourself. Origin to pole, as the distance from origin to pole increases, omega n increases. So as the frequency, as omega d and omega n increases, the time specifications delay time, rise time, and peak time, all are opposite to frequency, all are decreases. Next, so as zeta decreases, percentage of MP increases. The system less relative stable. System is less relative stable and more oscillatory. More oscillatory. Next, any more point? And one more thing completed. One more thing. The optimum range of percentage of peak core suit is the optimum range of percentage of peak core suit is 5% to 25%. Peak core suit should be 5% to 25%. It should not be more than 25%. It should not be less than 5%. What happens if it is more than 25%? If the peak core suit is more than 25%, what happens? For example, percentage of peak core suit is more than 25%. What happens? Blindly, I can say less relative stable and more oscillatory. What happens if it is less than 5%? What happens if it is less than 5%? Less than 5% means oscillations are very, very less. Less than 5% means, for example, it is 1. Oscillations very less means time durations are large like this. That means what happened? TR increases. So slow response. Slow response. That's why peak core should not be more than 25%. It should not be less than 5%. It should be between 5 to 20. It is 5 to 25%. It is nothing but what? Zeta value 0.4 to 0.7. It is nothing but zeta value, that is 0.4 to 0.7. Okay, right. Now draw the responses for this vertical movement of the pole. For this vertical movement of the pole, draw the responses. Come on. You draw the response for this vertical movement of the poles. Draw the response for vertical movement of the poles. As the poles are moving vertically, how the response is? So real part, see, real part decides the envelope to the oscillation. One real part means one envelope. Two real parts means two envelope. 1000 real parts means 1000 envelope. Real part gives the envelope to the oscillations. Real part of the pole gives envelope to the oscillation. Real part of pole gives the envelope to the oscillations. Envelope to the oscillations. Imaginary part gives the oscillations. Imaginary part gives the oscillations. Imaginary part of pole gives, already you know, imaginary part of pole gives oscillations. So now come on, draw it. Draw the responses. Right. Come on, draw the response. T, 0, C of T. For 3 poles, you draw it. As the poles moves vertically 1 to 3. what are the variation in the response? How to draw the response? This is one. How many real parts you are having? Only one real part, one envelope. One real part means one envelope. You draw the envelope to the oscillations. You draw envelope to the oscillations. Envelope to the oscillations you draw. Come on, envelope to the oscillations you draw. One real part, one envelope. So this is the envelope. Fold with respect to one. Ideally, we'll take one. Fold with respect to one. Come on, draw it. Okay. Fold with respect to one. Now in between draw the oscillations. Now in between draw the oscillations. In between draw the oscillations. Come on. 1 and 1 dash. 1 and 1 dash means more oscillations or less oscillations? Less oscillation. 2 and 2 dash more oscillation. 3 and 3 dash still more oscillation. So 1 and 1 dash is less oscillation. Less oscillation means time duration is more. Less oscillation means time duration is more. For example, 1 and 1 dash like this. This is for 1 and 1 dash. This is for 1 and 1 dash. Next, 2 and 2 dash. Slightly oscillations are more. 2 and 2 dash. Slightly oscillations are more. 2 and 2 dash. Slightly oscillations. Slightly oscillations are more. This is for 2 and 2 dash. Next, 3 and 3 dash. Still the oscillations are more. 3 and 3 dash. Still the oscillations are more. Still the oscillations are more like this. Like this, 3 and 3 dash. This is for 3. This is for 3. That's all. Now tell all are reach the what? Same duration. Settling time is same. All are reach the steady state at same time. For example, allowable tolerance plus or minus 2%. Settling time is same. Why it is same? Settling time is same. Why it is same? Because time constant is same. Settling time same. For time constant same. For all the poles, settling time same, time constant is same. All are reaches the same time. Same time reaches the steady state. What about delay? So what about the delay time, rise time, peak time? Tell. Delay time up to 50%. For example, here check it up to 50%. And up to 0.5 check it. This is TD1. TD1, this is TD1, this is TD3. For example, I'll take here. TD3, this is TD3. What happened? Delay time tell. Bolo, this is TD1, this is TD3. TD3. What happened? Delay time tell. Delay time, this is TD1. So delay time is going to be decreased. Delay time decreases. What about rise time? Rise time also decrease. This is TR1. This is TR1. This is TR3. This is TR3. This is TR3. That means what happened till rise time TR decreasing. What about peak time till decreasing? Peak time, this is TP1. This is TP1 peak time. TP1. This is TP3. This is TP3. What happened peak time till decreasing? So rise time, delay time decreasing, rise time decreasing, peak time decreasing, yes or no? So this is rest. This is rest time. TR3. TR. So TD decreasing, TR decreasing, TP decreasing. Next, what about peak overshoot? Tell. What about peak overshoot? Peak overshoot. So what happened? This is MP1. This is MP1. This is MP2. This is MP3. What happened? Tell. This is MP1. This is MP2. This is MP3. What happened? Tell. Peak overshoots are increases. Peak overshoots are increases. All are satisfied or not? Check it. Check it. What are the factors we written? Peak overshoot increasing, delay time, rise time, peak times, all are what? Decreases. Because here these two are increases means delay, rise, peak, all are going to be decrease. All are decreases. So all are decreases. Check it. Settling time is same. Check it. Settling time same. Check it. Settling time is same. Delay, rise, peak time decreases. Peak overshoot is increase. Settling time is same. So like this, you have to draw the response. Like this, you have to draw the response. In case 3 real parts, then you will get the what? 3 envelopes you will get. 1 real part, 1 envelope you will get. Sometimes in the objective exam, what they are doing, they are giving a pole location. They are asking the identify the unit step response. Identify the unit step response. For that, what you do? First, observe what factor is constant. Settling time is constant. In which option settling time is same for all you observe. Next, delay, rise time and settling time should be delay, rise and peak time should be decreases. Overshoot should be increased. First, to write the factors. Which option satisfies all that options? Which answer satisfies all the factors? Then that is the correct answer. Okay. So this is about the vertical movement of the poles. Next problem. Next, select the horizontal movement of the poles. Repeat the above problem. Come on, do it. 1, 1 dash, 2 dash, 3 dash. Poles are moving towards the left. Poles are moving towards the left. What happened to the time domain specifications? Zeta increases, very good. Percentage of MP decreases, very good. MP large. Omega n increases, more stable. What about TD, TP, and TR? What about delay, rise, and peak times? What about delay, rise, and peak times? Increases. TP constant for all. TR, omega D constant. So TD, TR, TP same. Listen here. So first poles are moving toward the left. Poles are moving towards the left means time constant decreases, settling time decreases. First point is poles are moving left. Poles are moving towards left. Hence, time constant decreases. And settling time decreases. Second one, imaginary part is constant. Imaginary part is constant. Hence, omega D is constant. As omega D constant, TP is constant. Because what is the formula for TP? Pi by omega D. Pi is constant, omega D constant. So TP is constant. What about TD and TR? TD and TR depends on zeta as well as omega n. TP and TR depends on zeta and omega n. So what happened tell here? Zeta and omega n. So for example, what happened omega n here? The distance is called omega n. The distance is called omega n. And what happened omega n? So omega n is increases. What about zeta? What about zeta? This is theta 1. Theta 1 is very large. This is theta 3, very small. So zeta equal to cos theta. Theta what happened? Decreasing. Theta decreasing. Cos 0 means 1. And zeta increase. Zeta increase means percentage of MP decreases. System more relative stable. System more relative stable. And what happened here? Zeta increases, omega n increases. So what happened TD and TR? So what is the formula for TD? 1 plus 0.7 zeta by omega n. Zeta increasing, omega n also increases. So what happened then? But change in zeta should be only between 0 to 1. But there is no restriction for omega n. Omega n, there is no restriction. Omega n may be change in omega n is large. Change in omega n is larger than change in zeta. That's why TD decreases. TD decreases slightly. It won't decrease large amount. Generally decrease slightly. Why? Because peak time is same. So all these changes occurs in the duration of peak time. That's why TD slightly decreases. Similarly, TR. What happened? Tell pi minus theta. Cos inverse theta called theta only. Omega D. Pi is constant. Omega D constant. Only theta varies. Theta what happened? Decreases. Theta decreases means TR is increases. So that means TR increases. TR is increases. Slightly. Slightly. Slightly TR increases. Slightly TD is decreases. Slightly TD decreases. But peak time is constant for all. Peak time is constant for all. Peak time is constant for all. Next, fourth one, what happened? Next, so peak time ho gaya, delay time, rise time completed. Then next, zeta increases. Zeta increases. So percentage of MP decreases. System become more relative stable. That's all. More relative stable. So this is the what. So that means imaginary part of the pole gives the peak time. Real part of the pole decides the settling time. These two factors we can fix it. Okay. So now draw the response for this movement of the poles. You draw the response. Can you draw the response? How many real parts are there? 3 real parts. 3 real parts means what happened? 3 envelopes you will get. You have to draw the 3 envelopes. Come on, draw it, all of you. Try to draw the response, all of you. Come on. Try to draw the response. Come on, draw it. First 3 envelopes you have to draw. 1 and 1 dash is more time constant or less time constant? 1 and 1 dash. Tau is large or small? Here tau is large. Tau large means what? Settling time is large for first one. As it moves, it is going to be decrease. First one is tau large, settling time is large. Tau large, settling time is large. That means what happened? It takes large time to reach the steady state. Like this. This is for TS1. Draw the envelope to this. So this is for 1 and 1 dash. This is for 1 and 1 dash. Okay, I can put 1 for example. Next 2 and 2 dash. 2 and 2 dash means little bit time constant is decreasing because left side moving na. Time constant decreasing. Time constant decreasing. Slightly less. This is for 2 and 2 dash. Slightly less. This is for TS2. Next 3 and 3 dash. 3 and 3 dash means what happened? Still settling time is very, very less like this. It settled very quickly because time constant is very, very less. This is for PS3. So what happened? 3 envelopes. So settling time is decreases because time constant is decreases. So next imaginary part is same. Imaginary part same means frequency of oscillations are same. Now draw the frequency of oscillations 1 and 1 dash. First draw for 1 and 1 dash. This is for 1 and 1 dash. Next 2 and 2 dash. Next draw for 2 and 2 dash. 2 and 2 dash what happened? Same peak time. But slightly what happened? Delay time decreases, rise time increases. Slightly delay time. 2 and 2 dash. Slightly delay time decreases. Slightly. And rise time slightly increases like this. But the peak time is same. But the peak time is same. One minute. Right? Visible na? Right. So next. Peak time should be same. Not only first peak, all the peaks should be same. Like this. Next 3 and 3 dash. Three and 3 dash. 3 and 3 dash means slightly delay time still decrease, but rise time still increase like this. But peak time is same like this. So what happened here? Tell for all these three, peak time is same. What happened delay time? 50%, 0.5 if you take, this is 1, this is 3. That means what happens slightly, this is 1, this is 3. So that means delay time decreases. This is 1, this is 3, this is 3, this is 1. That means what happened? Slightly rise time increases. This is 1, this is 3, na rise time slightly increases. Peak time same. What about peak core should tell? What about peak core should tell? This is called MP1. This is MP1. This is MP2. This is MP3. What happened? Tell. This is MP3. Peak or shoots are decreases. So now check all the factors. Settling time decreasing, peak time is same, delay time decreasing, rise time slightly increasing, peak or shoots are decreasing. Like this, you have to draw the response. This is for 1, this is for 2, this envelope for 2, this envelope for 3, this green color for 3, third envelope. So like this, you have to draw the, this is for 3, green color is third envelope. So like this, you have to draw the response. The system becomes more relative stable because it settled quickly, na? More relative stable. So less MP peak also decreasing means more relative stable. Okay. Next, one more thing. Right, good. Next, diagonal moment of the pole. Next, diagonal moment of the pole. Repeat the, you have to do it. You try to do it. Repeat the above problem. Come on, do it. 1 dash, 2 dash, 3 dash. Come on, do the homework. Do it. Take the break. 10 minutes break, you take it. By the time you try to write the answer for this, I'll discuss after the break. Okay. Take the break. Next. So here what happened? Theta is same first. Theta same. Theta same means zeta same. Zeta same means percentage of MP same. All this 1 to 3 having the same peak coefficient. All are having the same peak coefficient, same peak coefficient. Next, poles moving left. Poles moving left. Time constant decreases. Imaginary part increases. Imaginary part increases. Hence, omega d increases. Distance increases. Distance from origin to pole increases. Omega n increases. Omega d, omega n increases means omega d and omega n increases. Hence, TD, TR, TP all are decreases. But relative stability same. 1, 1 dash, 2, 2 dash, 3, all are having the same relative stability. Because horizontally more stable, vertically less stable, or diagonally same relative stability. That's all. You try to draw the response by yourself. You have to draw the response such that all should have the same peak coefficient. All should have the same peak coefficient. Okay, na? All should have same peak coefficient. Okay. So more angle, more relative stable. Less angle, less relative stable. Be remember. All are having same angle means same relative stable. For example, if I take this is 1 and 1 dash 0. Two and 2 dash. Next 3 and 3 dash. Come on, among these three, which is more relative stable? Come on, which is more relative stable? One or two or three. Just check the theta. Theta large, MP large. MP large means less relative stable. Check the theta, that's all. This is what? Theta 1. Very, very large. Theta 2. Very small. theta 3 medium. So what happened? Theta, which is larger here, theta 1 is large. Theta 1 greater than theta 3, greater than theta 2. So that means MP1 greater than MP3, greater than MP2. So this is less relative stable. This is more relative stable. First one, zeta, if opposite, you can write zeta 1 is less than zeta 3, less than zeta 2. Here zeta 2 larger compared to all zeta 2 larger. So zeta 2 larger than zeta 3, zeta 3 larger than zeta 1. So like this, you have to identify the relative stability. Okay. Next, I'll solve another two problems. Just time domain specifications only. After that, we'll start the steady state errors. Okay, jaldi jaldi. Come on, find the time domain specifier. We'll solve in the next page better. We'll solve in the next page. Two problems I'll give to solve it. Actually, these two problems not required. Just I want to give some conclusion. For that purpose only, I'm solving this problem. We need some conclusions. So based on the conclusions, especially that conclusions are important, especially with respect to zeta. What are the variations in time domain specifications with respect to zeta? If you ask it, then you should be able to tell. For that only these two problems. Find the time domain specifications. Find the time domain specifications. Two problems I'll give, you solve it. $25 divided by come on, this is one problem. Come on, jaldi jaldi. First solve the first problem. Find closed loop transfer function omega n zeta omega d. Find first omega n, next zeta, next omega d. First find omega n, zeta, omega d, td, tr, tp, percentage of mp plus or minus 2% settling time. Find closed loop transfer function. C of S by R of S equal to 25 by S square plus 4S plus 25. Omega n is 5. Zeta is 0.4. Next, come on. Omega D 4.5. Omega D is 4.5. Very good. 4.5. TD. TD. Omega D 4.58. 4.58. TD. Point 256. 0.256 seconds. TR 0.44 seconds. You check in your home. TP 0.698 seconds. Percentage of MP 25.38 percentage. Settling time 2 seconds. Similarly, solve here. First find closed loop transfer function. So what happened? 20 divided by S square plus 5S plus 25. It is not in standard form. Then 20 by 25 divided by 25 by S square plus 5S plus 25. Now come on. Get the omega n. Omega n is 5. Zeta is 0.5. Omega d. TD. TR. TP. Percentage of MP. 2% TS. Come on. I think omega d is 4.33 radians per second. TD is 0.27. 277 seconds. TR is 0.48 seconds. TP is 0.72 seconds. MP is 16.4%. Settling time is 2 seconds. So you check these answers. Now we'll make conclusion by comparing these two answers. See, what is the conclusion? I told very clearly, either you remembered or not, I taken omega n is same. Here also 5, here also 5. Just slightly I increased zeta. Just slightly I increased zeta. I told it either you remembered or not. As zeta increases from 0 to 1, what I told? The poles moves towards the left and near to the real axis, either remembered or not. As zeta increases from 0 to 1, as zeta increases from 0 to 1, the poles moves toward the left and near to the real axis. In this case, first step, poles are moving left means time constant decreases. Next, settling time decreases. Imaginary part decreasing like this, omega d decreases. Omega d decreases means TR, TD, TR, TP all are increases. Next, zeta increases means our poles are moving left near to the real axis means percentage of MP is going to be decreases. Check it one by one. So zeta slightly increase. What happened? Omega D should be decreased. What happened? Omega D here decreased. Here how much? 4.58. But here 4.33. As omega D decreased, what happened? TD increases. Check it. 0.25, 0.27. TR increase. 0.4448. TP increase. So 0.72. All are a peak also decrease. Settling time decrease. All the factors are satisfied. That means even zeta slightly changes. Zeta slightly changes. Each and every factor in the system is going to be affected. Each and every factor in the system is affected. So what is the conclusion tell? What is the conclusion tell? As so what is the heading? Variation in time domain specifications. Variations in time domain specifications. With respect to zeta. In the bracket, omega n is constant. Omega n is constant. We are not changing the omega n. Only zeta. Zeta changing means R changing. What is zeta tell? Zeta equal to what? R by 2 root of C by L. CL not changes. Just R increases. Omega n is what? 1 by root LC. So LC not changes. LC constant. Just zeta changing. Zeta changing means R changing. In RLC circuit, just R changing. In RLC circuit, in this circuit, just LC constant. This R is changing. Then what are the variations in time domain specifications? So what are the variations in time domain specifications? First one is as zeta increases from 0 to 1, the poles moves towards the left. The poles moves towards the left and near to real axis. In this case, first, time constant decreases. Second, settling time decreases. Third, omega D decreases. Fourth, as omega D decreases, TD, TR, TP increases. Next, percentage of MP decreases. System more relative stable. That's all. This is the time domain specifications. Next, go first. Steady state errors. Next heading is steady state errors. Put the heading. Okay, good. Next, steady state errors. So first, what is the error tell? What is the definition of error? Error. Error equal to what? Deviation of the output from the input. error equal to, error is nothing but deviation of the output. Deviation of the output from input. That is E of t equal to R of t minus E of t. R of t minus E of t. Steady state errors. Error at t tends to infinity. Error at infinity. That is ESS, denoted as ESS, equal to limit t tends to infinity E of t. Limit t tends to infinity E of t. Apply final value theorem. Limit s tends to 0, s into E of s. Limit s tends to 0, s into E of s. Okay. Next, consider the unity feedback system. Next, complete enna? Consider unity feedback system. Consider unity feedback system as shown in figure. Consider unity feedback system as shown in figure. R of s. G of s. C of s. 1. Come on. So here E of s. Here E of s. Find E of s here. Find E of s. Bolo, what is E of s by R of s? E of s by R of s, you tell. Up to E of s, what is the path gain? 1. Up to E of s, path gain 1. This loop touching divided by 1 plus opposite sign of loop gain. What is the opposite sign of loop gain? Minus G of s, opposite sign means plus G of s. That means what is E of s? Tell. R of s by 1 plus G of s. E of s equal to R of s by 1 plus G of s. 1 plus G of s. Next, steady state error. Limit s tends to 0, s into E of s. Substitute E of s. Limit s tends to 0, s into what is E of s? R of s by 1 plus G of s. R of s by 1 plus G of s. So now, so steady state errors depends on what? One is R of s, second one is G of s. G of s means system, H of s should be 1. Steady state errors are valid for only unity feedback systems. Steady state errors are valid or calculated. First step, steady state errors are calculated to only closed loop stable systems. Closed loop stable systems. We don't calculate steady state errors for open loop systems. It is for only closed loop, that also stable systems only. For unstable system, steady state error is ESS is unbounded. Unstable means what? The response goes to infinity, that is plus or minus infinity. It may be plus infinity, it may be minus infinity. For unstable systems, how to find means just you have to find C of t. If it is plus infinity, then error plus infinity. If it is minus infinity, then it is minus infinity. Steady state errors are calculated to only unity feedback system. Steady state errors are valid only unity feedback systems. Only unity feedback systems. Unity feedback system. If non-unity feedback system is given, if non-unity feedback system is given, if non-unity feedback system is given, then it is required to convert into unity. It is required to convert into unity feedback. How to convert, I'll discuss. Unity feedback. We require to convert into unity feedback. How to convert, I'll discuss it. No need to worry. Next. Steady state errors are depends on two factors. Steady state errors are depends on two factors. Steady state errors are depends on two factors. First one, type of input, that is R of S. First one, type of input. In the bracket R of S. Second one, type of system. Type of system. That is G of S. H of S should be equal to 1. H of S should be equal to 1. H of S should be 1. Okay, na? So steady state errors are calculated to only stable systems only. And now put the heading type of input. Now put the heading first one. Type of input. Type of input R of S. And now tell type of input you tell. What are the different types of inputs for which calculated steady state error? What are the different types of inputs for which calculated steady state error? Step, ramp, and parabolic. Very good. Errors are calculated to only negative feedback. Stable systems means negative feedback systems. Stable system is a negative feedback system. Generally, errors are calculated to negative feedback system. So it should be stable. Okay. That's why I written R of S minus C of S. Na. Okay. Or if you want positive feedback, then it should be inverted for the input. Why unnecessary things? Okay. Right. Errors are calculated generally for negative feedback systems only. Okay. Be remembered. Okay. Now type of the input. What are the different types of input we will calculate steady state errors? Means one is step, second ramp, third parabolic. I'll draw the tabular form. First input. R of t. So what is R of t for step input? A into U of t. Here A t into U of t. A t square by 2 into U of t. A t square by 2 into U of t. Next, steady state errors. So what is steady state error per step? A by 1 plus Kp. A by Kv. A by Ka. Next, error constants. Error constant. Kp called position error constant. Kp called position error constant. What is Kp? Anybody? Limit s tends to 0, g of s. H of s should be 1. H of s should be 1. Kv is called velocity error constant. What is Kv? Limit s tends to 0, s into g of s. Ka is called acceleration error constant. Ka equal to limit s tends to 0, s square into g of s. That's all. Come on, do it right. Completed. Right. Type of non-unity feedback system, it will come at the end of the steady state errors. I'll discuss how to find type for non-unity feedback, how to calculate steady state errors also I'll discuss. Okay, wait some more time. Next, type of the system. Next, put the heading type of the system, second. That is G of S. H of S equal to what? Type of the system. Come on. Type of the system. Write it. The standard form of closed loop system. The standard form of closed loop system is described as open loop transfer function of a unity feedback system. The standard form of closed loop system is described as open loop transfer function of a unity feedback system. Unity feedback system. Okay, that is G of S equal to, that is S equal to K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power n into 1 plus S tau a, 1 plus S tau, and so on. H of S equal to 1. This S power n represents the type, so type n system. Type n system. Now consider the step input. Consider the step input and different types of the system. Different types of the systems. So take a step input. Step. So what is the steady state error? ESS equal to A by 1 plus Kp. Where Kp is, what is Kp? Limit S tends to 0, G of S. Where Kp is limit S tends to 0, G of S. So now, come on, do it. Limit S tends to 0, G of S. Now take type 0 system. First take type 0 system. Calculate Kp for type 0. What is G of S for type 0? Here S power, n value 0, that's all. Type 0 means n value 0. That means K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power 0 into 1 plus S tau A into 1 plus S tau B, and so on. Now calculate here Kp value, come on. Find Kp. Kp equal to what? Limit S tends to 0, G of S. G of S substitute here K into 1 plus S tau 1, and so on, divided by S power 0 into 1 plus S tau A, and so on. Come on, S tends to 0 is substitute. If you substitute, this will become 0, this will become 0, this will become 1. Then what is the answer? K. Kp equal to K. Then find the steady state error. What is the steady state error? Tell here. ESS equal to A by 1 plus Kp. Kp called what? K. That's all. Then A is constant, 1 is constant, K is constant. Steady state error is what? Constant. Steady state error is constant. Error is constant. That's all. Steady state error is constant. Next, type 1 system. Type 1 system. Type 1 system. Calculate Kp value for type 1 system. So for type 0 system, step input error is constant. Now type 1 system, calculate Kp. Come on. Calculate Kp. Type 1 means what is G of S? Tell. What is G of S? K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power 1 into 1 plus S tau A into 1 plus S tau B, and so on. So calculate Kp value. Kp limit S tends to 0, G of S. Come on, get it. Limit S tends to 0. What is G of S? Tell. K into 1 plus, come on, S in S tau 1, and so on, divided by S power 1 into 1 plus S tau A. S tends to 0, substitute here, 0 substitute here, 0 substitute. What is the answer? K by 0 becomes infinity. Then what is the steady state error? ESS equal to A by 1 plus infinity becomes what? 0. steady state error becomes 0. Type 2 system 0. As long as here S term present, as long as S term present, Kp becomes infinity, error becomes 0. Type 2 also same, type 3 also same, type infinity also same. That means what you observed here, as type increases, steady state error is decreases. As type increases, steady state error is decreases. As type increases, steady state error is decreases. And one more thing, I will assign the value for the inputs so that it become very easy to solve the problems. Step means here I can write t power 0 na. That means step means 0. Just remember, you remember, step t powers I will assign for the inputs. T power, step means t power 0, so step is 0. Ramp means t power 1, so ramp value 1. Parabolic value 2 because t square. T powers you remember. Degree of t powers you remember. Step t power 0, so 0. Ramp t power 1, 1. Parabolic t power 2, 2. Whenever type equal to input, see here I assign the value for step is 0. So step is 0, type is 0. So type input step 0 అంటే S power T power same, then error is constant. S power and T power both are same, then steady state error is constant. S power T power same, then steady state error is constant. That means what happened? Type equal to input, then error is constant. So simple conclusion is, whenever type equal to input, then steady state error is constant. Type is greater than input. Type is greater than input. Input values remember, step 0, ramp 1, parabolic 2. Type greater, steady state error is 0. Type is less than input, then steady state error is infinity. Type is less than input, steady state error is infinity. By knowing this, we can conclude that steady state errors are required to calculate only 3 cases. Steady state errors are required to calculate only 3 cases. What are the 3 cases? Means type 0 and which input? 3 inputs only is there. 0 input is what? Step. So that means type 0 step input you have to calculate. For that only we'll get the error is constant. What is that error? A by 1 plus Kp. Kp also K. So whereas type 1 and ramp input. Type 1 system and ramp input is given, then you have to calculate steady state error. What is the steady state error for this? A by Kv. Kv is called K. And type 2 and parabolic inputs. Type 2 and input also should be 2. So that is parabolic. Type 2 and parabolic input. What is the steady state error? A by K. Remain all the cases, the error may be 0 or infinity. Remain all the cases, error may be 0 or may be infinity. Type 0 step input, you have to calculate error. Type 1 and ramp input, you have to calculate error. Type 2 and parabolic input, you have to calculate. Remain cases, directly we can write either 0 or infinity. Remain all the cases, we can write the error either 0 or infinity. Okay, na? Steady state errors are required to calculate only 3 cases, that is type 0 and step input. Steady state errors are required to calculate only in 3 cases. That is already written. Type 0 and step input. Next, type 1 and ramp input. Type 2 and parabolic input. Remain cases. Steady state error may be 0 or infinity. That's all. Next we have to solve the problems. What we'll do? Block diagram problems, almost everything we solved in the class itself. Okay, solve. Second chapter, volume 1. 10 minutes is there, we'll see. First question I solved in the class itself, we can check it. First question I solved in the class itself. Chapter 2, volume 1. Question number 1 solved in the class. You can check it. Question number 2. In question number 2, we are having a 2 forward paths and 3 loops we are having. Question number 2, if you write the transfer function C of S bar of S, open the booklet all of you. Open the booklet all of you. Question number 2, observe it. One by S, 1 by S, 1 by S, 1 C of S. This is the diagram. Find the transfer function. So what happened here? This is the what? Here -1, this is -1. How many forward paths? 2 forward paths. One is straight, like this. Second one is through 1 by S. How many loops? This is one loop L1, this is L2, second loop. Third loop is like this. This is the third loop. Here not touching third loop. This is not a node. It is not a node. So that means find the transfer function. C of S by R of S equal to first forward path 1 by S cube. All the loops touching. Second forward path 1 by S. This is the third loop. Second forward path 1 by S. All are touching. All the loops are touching. L1 touching to this here, L1 touching, L2 touching, along the path L3 also touching. Divided by loop gains you write. First loop gain 1, opposite sign of first loop gain 1 by S square. Opposite sign of second loop gain, so 1 by S square. Opposite sign of third loop gain. What is the third loop gain? Tell 1 by S minus 1, 1 by S minus 1. Minus minus plus. So that means opposite sign means minus 1 by S square. Now these two cancelled. So then solve it. Numerator 1 by S, take it common. What I can write? 1 plus 1 by S square. Denominator also 1 plus 1 by S square. This cancel. What is the answer? 1 by S. Third question you can solve by yourself. Simply, we are having the 5 loops. Third question, we are having 5 loops are there. You try 5 loops. Similar question almost I solved it. There are 5 loops are there and 2 non-touching loops are there. So 2 non-touching loops are there. You try, you will get the answer. Third one. Third one you try. Okay, na? Fourth one also simply draw the signal flow graph and then solve it. Fourth one. Sorry, third one I'll solve it. Some people they may not able to solve. 1, 2, 3, 4, 2. Right. This is the diagram. Come on, solve it. So how many loops are there here? This is L1, this is L2, this is straight coming back. This is L3, this is L4 like this. This is L5. Now get the answer. Come on, find the transfer function. C of S by R of S, you solve it. You'll get the answer. So C of S by C of S, I'll write here. C of S by R of S. Now come on, first forward part 2 into 3 into 4. 2 into 3 into 4, 24. 2 this L1 touching, L2 touching, L3 like this. This is L3. L4 like this. This is L4. L4 like this. This is L4. So this is L4. Right. Next. So to the first forward part 2, 3, 4. L1, L2, L3, L4 touching. L5 non-touching. So 1 plus 0.5. 1 plus 0.5. Plus second forward path 5 into 2, 10. To this, what happened? Here L3 touching, here L5 touching, here L2 touching. What is non-touching loop? Tell here -1 now. Non-touching loop is L1. So that means 1 plus 3. 1 plus 3. To the second forward path 5 into 2, 10. L1 touch, L2 touching, L3 touching, L4 touching, L5. Only L1 non-touching. Divided by delta. 1 plus 3 plus 4 plus 24 plus 10 plus 0.5. Individual loops. Opposite sign of individual. L1 opposite sign of L1, opposite sign of L2, opposite sign of L3, L4, L5. Plus 2 non-touching loops. L1, L2 touching, L1, L3 touching, but L1, L4 non-touching. L1 is 3, L4 is 10. This is L1, L4 non-touching. Next, L1, L5 also non-touching. L1, L5. L1 is 3, L5 0.5. L1, L5 also non-touching. Plus, next L2, L3 touching, L2, L4 touching, L2, L5 non-touching. L2, L5 means 4 into 0.5. L2, L5 is non-touching. Next, L3, L4 touching, L3, L5 also non-touching. L3, L5, L3, 24, L5, 0.5, L3, L5. Next, L4, L5 touching. You solve this. You solve this total, you will get the answer. I think 0.93 or something. 76 by 88, you will get answer. Next, fourth bit you can solve by yourself. Just go by signal flow graph, you will get the answer. Just 2 forward paths. I think 5 loops are there. L1, 1, 2, 3. I think 5 loops. Yes, 5 loops are there. You try to solve it, you will get the answer. Fifth one, verify the transfer function. Just verify the transfer function. Fifth one, verify the transfer function. Transfer function of not required, na? Just I told now to solve, I told it. Write the equation for V naught, write the equation for Y. You will get the answer. Fifth one, from signal flow graph. First from SFG. From SFG. Bolo. Press SFG. What is X? I want X is incoming branch to X is incoming branch to V naught. Write the equation for V naught. What is V naught? Tell. V naught equal to what? I of S into X. I of S into X. From network, what is V naught? Tell from network. I into 1 by SC. I into 1 by SC. That means X equal to 1 by SC. X equal to 1 by SC. X equal to 1 by SC. Next, similarly, Y from SFG. From SFG. What is from SFG? What you have to write? Y is incoming branch to I. Y is incoming branch to I. Incoming branch to I. Write the equation of I. I equal to what? Tell. Vi by R plus V naught by V naught of S into Y. V naught into Y. Next, from network, write I. From network, I equal to what? Tell. Vi of S minus V naught of S divided by R. Now compare this two. Compare. So Vi is there. 1 by R is there. That means Y equal to what? Minus 1 by R. Minus 1 by R. Then you will get the answer. Sixth one already I solved in the class. Seventh one already I solved in the class. Eighth one you try to solve it. That's all. So this will complete the solutions for chapter 2. Next, steady state error questions you have to solve. You have to solve the problems in steady state errors. Volume 2, try to solve all the problems by yourself. One big question is there, but try to get the answer for that. If you are perfect in shifting the chapter 2. In volume 2, question number 22, what you have to do? In volume 2, question number 22 is a big diagram. Drawing also takes the time. I'll give the idea. The second summing point should be shifted to first summing point, then automatically we'll get the answer. If you have an idea on block diagram reduction technique, then only you'll get the answer. Or otherwise, whatever the procedure solved in the booklet, you go by that. Simple logic means here C naught, here C1. That means to the input connected C naught and C1. To the input connected C naught and C1. Summing point 1 by S here summing point 1 by S P minus A1 A2 next feedback path. This is the feedback path. This is output na. This is feedback path. Feedback path connected to what? B0 and B1. Feedback path connected to B0 and B1. B remember. B0. This is the diagram. This we have to convert into like this. Input should be here, connected blocks is X. And next here summing point. Remain all the blocks are Y. Before P, whatever the blocks are there, all are Y. And total feedback path is Z. Total feedback path is Z. This is Z. Simple logic, you shift this summing point to a head of 1 by S because we want only one summing point, not two summing point. Just shift here to here, we'll get the answer. That's all. Before shifting, what is the path gain? Tell C1 by S or B1 by S or B1 by S. B1 by S. C1 by S. Either like this or like this, same na. So C1 by S and B1 by S. B1 by S. If I shift to here, what I will get tell here? If I shift to here, what is the path gain? Tell. If I shift to here, in case this point will come to here, for example, will come to here, what is the path gain I'll get? C1. Bolo, what is the path gain I'll get? C1 into 1 by S into 1 by S into P. P is there here also. C1, P, C1. C1, P by S. C1, P by S. Here also B1, P by S. B1, P by S. After shifting, what I am getting? Tell C1, 1 by S, 1 by S, P. And what I am getting? C1, P by S square I am getting. Or B1 P by S square you are getting. That means what I want? Actually C1 P by S I want. That means I need to product here yes. I need to product here yes. So that what happened? Yes, get the cancel. That means it will become C1 yes. This will become B1 yes. So now B0 and B1 both are parallel. B0 and B1 is both are parallel. Both because all are connected to the summing point. Na? B1S also connected to the summing point. C1 of S also connected to summing point. So B0 is just like parallel. B0, B1 parallel. C0, C1 parallel. And this will become what? C0 plus C1S. This will become B0 plus B1S. B0 plus B1S. B0 plus B1. After the class, you shift this point here, you write here SS and observe it, B0 and B1 become parallel, C0 and C1 become parallel. Then Y means, Y is nothing but all these blocks you have to simplify. You simplify all these blocks, you will get the Y. Now tell what is Y? Tell forward path gain from here to here 1 by S square. 1 by S square divided by, this is one loop, this is another loop. This is one loop like this. Second loop is like this. This is the second loop. What is the loop gain? 1. Opposite sign of this loop gain. So A1 by S. Opposite sign of second loop gain means plus A2 by S square will get. That means if we solve this 1 by S square plus A1S plus A2 you will get. Like this you have to solve. Just you draw a equivalent diagram by shifting this summing point, head of the summing point. Here block gains are producted, then you analyze, automatically will get the answers. Okay. So I'll close here. If you have any doubt, you can ask it. Sri Charan.
Hello, sir.
Tell.
Sir, impulse, if you give input as impulse, we will not get the error, sir.
Impulse, is it having steady state term?
No, sir.
Impulse exists at infinity?
No, sir. No, sir.
Well, then how can you get the steady state error?
Okay. Normal error it will get.
Normal error means what?
Sorry, sir.
Cannot find error na. Error means
Okay,
what?
okay.
Input minus output.
Input minus output, yes.
Input where exists?
At
In
zero.
0.
Yes, sir.
That also at 0 infinite magnitude. How can you find error, man?
Yes, sir. Correct.
Errors are not defined for impulse. Okay?
Okay, sir. Thank you, sir.
Next, Susmita.
Good evening, sir.
Good evening, Chappamma.
Sir, a question lo peak value of the response అడిగారు కదా సార్.
అవును.
ఆ క్వశ్చన్ లో నేను సి ఆఫ్ టీపీ అంటే మనము అవుట్పుట్ రెస్పాన్స్ ఎట్ ఫస్ట్ పీక్ అంటే డిఫాల్ట్ గా మనం ఫస్ట్ పీకే తీసుకుంటాం కదా సార్.
డిఫాల్ట్ ఫస్ట్ పీకే డౌట్ ఏముందా?
అప్పుడు టీపీ అంటే నేను ఫస్ట్ పీక్ వాల్యూ క్యాలిక్యులేట్ చేశాం కదా సార్. మనం డైరెక్ట్ గా ఆ వాల్యూ సబ్స్టిట్యూట్ చేస్తే సిస్టమ్ లో ఏమో ఆన్సర్ రాదా సార్ దానికి?
How can you get it? It is a very big expression. How can you get it?
అంటే సి ఆఫ్ టీ ఈజ్ ఈక్వల్ సి పవర్ ఆఫ్ మైనస్
You simplify
3t sin
that.
4t.
What value will substitute there? Where you will substitute? In C of t, you will substitute that t equal to tp.
అట్లే చేశాను సార్ నేను.
How can you get it? What is zeta value? What is omega n value? You should know all the values, na?
Yes sir.
Then only we'll get the answer. Why all that simply use C of tp? AK plus MP use directly will get the answer, na?
Okay sir.
Okay, na?
Thank you.
Why to make complicated? Tell.
Okay sir.
Akansha,
Hello,
tell.
so audible?
Audible, tell.
Sir, in the question it was given expression of CT, and I think the girl was asking the same thing.
Speak loudly, speak loudly.
Hello?
Tell.
So I think the girl was asking same thing that at TP can we find CTP to find a maximum?
Find it. If you are getting answer, well and good. You try.
Sir, I am not getting answer, but
That's why follow the procedure what I told, because there that expression gives still very big.
Yes, sir. Means like you said, maximum peak overshoot.
You follow the procedure. You are doing the wrong analysis. Okay. You want to substitute here TP.
Yes, sir. Means I was just
substitute TP. What you will get? Tell. What is zeta? Who will write zeta? Who will write omega n?
So the expression was given e to the power minus 3t sin 4t.
You solve it. If you get the answer, well and good, na?
Okay, fine, sir. Sir,
Or you differentiate peak value of the response. Maximum value, right? It is a maximum value. Differentiated this, then also you'll get the answer.
Okay.
After finding all, only will get that expression.
Okay, sir. Sir,
After
and
substituting, how will find C of TP?
uh,
After differentiating this, dC of t by dC we have to do. How to get maximum value? Tell. By differentiating. Where at t equal to TP, then after that only that expression you are getting.
okay.
What
sir.
you are telling, I will do the derivation. You do a derivation. Next to another one day it will take.
Okay, sir.
You have to write answer within a minute, na?
Yes, sir.
Then why you want to go by very lengthy procedure? Tell. You will get the answer, no doubt.
Okay.
If you
Okay,
don't
sir.
do the mistake, you will get the answer, no doubt.
Okay, sir. Sir, and you said that the real part gives the envelope of oscillation.
Real part of the pole.
Yes, sir, real part of the pole. So I didn't understood means.
I told very clearly in the basics itself. E power is nothing but real part of pole. I told it very clearly.
Yes, sir. So means one envelope means there will be only one oscillation till.
Huh?
So what do you mean? Means what this one envelope mean? I didn't understand.
What one? One I didn't get. What is one?
Sir, while the poles are moving vertically, there was only one envelope of oscillation.
Tell. Poles are moving vertically. Okay.
So there was only one envelope of oscillation now.
One frequency, different frequency. Check it. Omega D same or different?
So yes, sir, here it's different, but only vertically. Vertically when it was moving only.
Vertically. Okay. Take it vertically. Vertically. Tell.
So here envelope of oscillation is one.
Oscillation 1 is what, what amma? 1 dash is a pole location.
So what you said that a real part of pole gives oscillation.
Real
of-
part of pole gives the time constant. Read here, time constant, not the frequency of oscillation.
So in next page.
Imaginary part gives the frequency of oscillations. Here tell poles are moving, time constant decrease, settling time decrease. Imaginary part is same, frequency of omega d constant. Omega d means what? Frequency of oscillations.
Okay. So I just didn't understand that envelope of oscillation. What?
Huh?
So envelope of oscillation, how to draw that in response? You were drawing now.
I didn't get your question. What do you want?
So
Omega
envelope-
imaginary part constant. Then what?
So envelope of oscillation meaning I just want to know.
Huh?
Envelope of oscillation.
Oscillations.
Envelope of oscillation you said.
Envelope three real parts are there, na?
Yes, sir.
3 envelopes are there.
So what does that mean?
3 time constants, 3 settling times.
Okay.
I told na 3 envelopes, 3 oscillation, 3 envelopes, 3 time constants, na 3 settling times, na.
Okay.
That's why we drawn 3 different settling times. Why we drawn 3 different settling times?
Okay, sir.
Got it, na?
Yes, sir. Yes.
Okay. Any more? Venkatesh.
Sir, what does the word mean envelope, sir?
Envelope means it is oscillations. Peaks will decide. Peak and valley point will decide. The oscillation should be in the envelope only.
What is mean by envelope, sir? I didn't understand the word envelope, sir.
Envelope means covering the peak values. In that only oscillation should be there. Edges, it is edges, na envelope. Communication studied,
No, sir.
in the BTech communication it didn't study.
No, sir.
Signals and systems also it didn't study.
Signals and systems.
In the envelopes are not there for oscillations. Peak
Until now,
values, that's all.
one chapter not completed, sir.
Huh?
Signals and systems. In signals and systems,
This is
one
called
chapter.
envelope. For example, if oscillations you are drawing, where peak will end? How will decide that peak? Valley point, how will decide? Between the envelopes only, na?
Oh.
Envelope decided by real part. That means how fast it is. That decided by time constant. Based on the time constant, the decay will be there.
Okay.
In that only you have to draw the oscillations.
Okay, sir.
Okay, na?
Okay, sir.
Next, any more?